All right, so let's say that we have the K that we came up with, I think it was yesterday. It was 1.43 times 10 to the 10th. Okay? So let's say, I'm just making up a new equation if I don't want to look up yesterday. Let's say that our reaction was this. Now, what would that tell us about our reaction? Don't quote me what I wrote on the board from before. I have to read that. All right, what would that tell us about our reaction? If you want, that's the example. How long? You're asking me those things? A long time. Today, 76. Yeah. That's a long time. Then ask me, do I need to write this down? It's a long time. So then ask me, well, do I need to write this down? So, what does this tell us? All right? Is this K a K that's much bigger than 1 or much less than 1? Two greater than signs, first of all, means much bigger than 1. And this means much less than 1. That's the first thing you should know. Y'all know that? Okay, you should know it from math class. So, if it's much bigger than 1, it means the forward reaction is favored or the lots of products are produced. So, if I come back over here, okay, that means I have mostly NH3 produced, and this is mostly used up. There might be a little left, but it's mostly used up. So to put this in context for you, you remember a week and a half ago when we made salt? Several of you said to me, well, can I eat my salt? And I said no, because there could be some unreacted HCl. It was a reaction very similar to this. It was an equation with a very high K. Most of the baking soda and HCl reacted beautifully, made salt, water, and CO2. We evaporated the water off, the CO2 was given off into the air, and we were left with salt. Okay? Very large K, it turned into mostly salt. However, some of it might not have been used up, and you might have had some unreacted HCl, which I didn't want anyone to do what with? Accidentally eat. Okay? Now, if you had a reaction such as one where you had all right, 1.27 times 10 to the negative fifth. Now, what does that tell you? What do you have mostly left over after it reacts? You have mostly reacted, okay? You would have mostly H2 and I2 in the container. Okay? You would make very little HI. Okay? Very little. You would get virtually none. So let's say that Alexis was in the business to make HI. Would he be happy with what he was doing to make HI if that's what he got? No, he'd go broke. He would need to do something to increase his production of HI. Now, there's lots of things he can do to shift his equilibrium to try to make more HI. Okay? And that's where the rest of our discussion for today is going. How can we shift our equilibrium to make HI that we're clearly not making based on that K? Most of what we're getting is H2 and I2 because my K value is so low. So if I have a really low K, I have reactants. If I have a really high K, I have mostly what? Product. I get off the phone. Okay? Everybody caught up? Are you with me? Okay. Now we're going to talk Le Chatelier. Le Chatelier. All right? Le Chatelier is about how can we make the shift to increase Alexis's chances of making more of that HI. Now, first of all, according to Le Chatelier's principle, we can shift the direction of equilibrium. So, the equation that we just had mostly reactants, right? We don't want a lot of reactants. If we're in the business of making something, we want what? We want product. If we want product and we're getting more reactants, we got to shift it to make product. We can do that by changing things. Okay? So, we're going to talk about what things we can change and how to do that today. Now, tell me this. What Le Chatelier's principle? Tell me what Le Chatelier said. I need something more than that. I had two people do the first three in their own words. Okay. If you can't tell me what Le Chatelier says, or say it in your own words, you need to write what's in blue right there. Okay? If you can't tell me what Le Chatelier said in your own words right now, you don't have a clue. Can't do it. You need to write that down again. If a system is subjected to a stress, it will automatically readjust to minimize the stress. Okay? If a system at equilibrium is subjected to a stress, it will automatically readjust to minimize that stress. Now, the next board is going to tell you what the three stresses are again. I hope you can tell me that much. What are the three stresses we said we were going to talk about? Temperature, pressure. There we go. At least we got three of them. Making some progress here. That is the current plan. Tomorrow we're going to finish with Chatelier. What's 14 and 4? We're going to finish with Chatelier and start Play-Doh. Because we'll only have an hour, we will spend most of them on the Chatelier. Just practicing it. Because by the time I finish at 3:30, if you're like the first period, you're going to go, I don't get it. Hopefully not, but a lot of them looked at me like I had three heads and they left. All right, the only thing I want to point out is this one. Pressure. They don't have to say pressure. They can change volume. Who follows that? Whoa. What? Boil. Boil. Okay. Okay. You have the right law. Just don't say boil less. Okay. It's Boyle's law. How are pressure and volume related to each other? How are pressure and volume related to each other? It is Boyle's law. That is exactly right. So how are they related? Because remember, they're not necessarily going to have to give you pressure as a stress. They could change it to volume because you know how they're related. So how are pressure and volume related to each other? Temperature is constant. So how are pressure and volume related? Okay, I'll give you two options since you did so well with Boyle's law. They're either inversely or directly. You got to pick there. It's proportional. Inversely or directly?
Inversely proportional.
Okay. They're inversely proportional. So, if they happen to say that you have a decreasing volume in the question, what does that mean for you in terms of pressure? That means pressure does what? That means pressure increases. Now, I would hope, for your sake, that they would just say pressure increases. However, do they have to just plain out say the question, by the way, pressure increases? No. They could say that volume decreases because y'all know pressure and volume are inversely proportional. One goes up, the other goes down. Concentration and temperature are not something you're going to have to worry about because they're not going to give that to you in terms of one of the calculators. Okay? Now, we're going to talk about Le Chatelier's principle. This is the part the students don't like because they're very rule-laden. Okay? Rule-laden. You got 2 rules to go with every part of Le Chatelier. So you got to learn the rules. Laden. They're heavy in rules. They're very rule-driven. L-A-D-E-N. All right. So the bold parts are just the rules. For those of you who like the reasons why, the parts that are not bolded are the reasons why. Okay? So for those of you who only want to know the rules, when you finish writing, underline the parts that are bolded because that's the part you have to make sure you know. The parts that are not bolded are the reasons behind the bold part. Okay? So, if I'm one of those people who just needs to understand what the rule is, so I don't care the reason, I just need bold. A lot of you are curious kind of people, and you need to understand the underlying principle behind it. That's the non-bold part. Okay? I'll explain after you've written. All right, you got it? So, remember, Le Chatelier is talking about things that are at equilibrium. Alright? So you've got so you have a reaction that's at equilibrium. It's happy. And we just went and tampered with it and upset its natural state. Came in and added some more reactions. Well, if I add some reactions, we are trying to get back to at equilibrium, right? Well, if I add reactant, the only way I can get back to equilibrium is to do what? To use it up, to get rid of it. Okay? So that's what this is talking about. If I add a reactant, I have to do what? I have to use it up. That's the reason behind what's going on in the rule. However, if you're just a rule person, if you add a reactant, I have to shift to the opposite side. Okay? Now, the second rule. We don't have to add. We could also do what? We can remove. If we remove a reactant or product, you got to build more up. You got to make up for what you took out. So anytime you remove a reactant or product, you have to shift to make more. So it shifts to the side you removed it from. That is another way of saying you shift to the same side. Okay? You shift to the same side. Yeah. How much you got left? Yeah. All right, got it? Fine. So let's talk about applying. So here's the equation. And we're going to do three different things to this equation. Yesterday. There's your math teacher over there.
Oh, I'll be talking to you tomorrow.
Yeah, all the classes are important.
Why?
No, well, not for this one. Third is pretty close to the normal time because you've got to run the lunch. Unfortunately. Gotta find this book. 8:20 to 9:30 belong to class under them. So we got an hour. Looks like that 10 minutes for first. Second, looks like that's an hour and 25. Oh, thank you. Oh, it's an hour and 25. Then you got 11:05 to 1 o'clock for the third period. But you got to take out 25 minutes for lunch. So like I said, third will be right at about an hour and a half. That's not going to change. And then fourth period is right at an hour, 1 to 2. And then we go to the talent show from 2 to 3. I'm assuming they're going to call us. They're supposed to deliver wristbands during third period, but I'm not seeing any wristbands yet. I'm assuming that's tomorrow. That's rare. Yep. Yep, we will get wristbands because we're all paid. Uh, Maybe the small select set of chorus or the national anthems might want their autograph. All right, so when you look at this, first of all, we're adding oxygen. So which rule are we analyzing? the top, and we're adding. So what does the rule say? Got that part. What does it say to do? To the opposite side. All right. So if we add, we're going to the things had issues all day. All right, so we're going to opposite side. So what side is oxygen on? All right, it's a reactant. So we're going to the product side, right? So if this is a reactant, we're going to the product side. So that means we're going to shift right. So in order to get back to equilibrium, this reaction has to shift to the right. What I did just makes sense to anybody other than me. At least I got one. That means we're at equilibrium. We were at equilibrium. I added oxygen and just messed up the equilibrium. So this reaction is trying to get back to equilibrium. The only way I can get back to equilibrium is to use up this oxygen I just added. So I shift to the right in order to get back there. Depends on what I ask. At the moment, that's all I wanted to talk about was whether we were going to shift right or left. Now, if I shift to the right, what kinds of things are going to happen? So, if I shift to the right, what's going to happen to the concentrations on the right and the concentrations on the left? Anytime I shift to the right, what happens over here? The concentration goes what? Increases. What happens over here? It decreases. That is true of whether we're talking concentration, whether we're talking temperature, or whether we're talking pressure. Every single time you say shift to the right, whatever's on the right will increase, whatever's on the left will decrease. Now, if you say shift left, whatever's on the left will do what? And whatever's on the right will do what? Yes. Okay? So, if I change this particular question, we remove nitrogen, and let's just say I ask what happens to the concentration. Remember, brackets are concentration of NO. Yeah. They're concentration. All right, so let's say I'm asking for the concentration of NO. Okay? So, what's the rule? If I go back for remove. So it means the, okay. So if I, wrong way. So if I remove nitrogen, it goes to the same side. So what side is nitrogen on? Now, which one of those is nitrogen? It's on the left. Okay. So same side is the left or the reactive side. So it shifts left. So that means whatever's over here is going to do what? Increase. And whatever's over here is going to do what? All right. Now tell me where NO is in this picture when you superimpose it up here on that. Take this and put it up here. Is NO increasing or decreasing? And you put it up there. Decreasing. Okay. Suppose I ask about oxygen concentration and this one. Okay. If I remove NO, what is the rule if I remove NO? Okay, same side. Okay. I'm asking what's happening to that concentration. So if I remove NO, which way is it going to shift? Okay, if I remove NO, it goes to the same side. What side is NO on up here? Look at NO. NO is by itself. That's nitrogen, that's oxygen, that's nitrous oxide or NO2. Okay? So, same side would be the right. Or the product, as you say, which is exactly right. So, if I shift to the product, what happens to the product? What happens to the reaction? So, superimpose this and on top of the reaction. All right, so what happens here? What happens to this side? So O2 is where? So it does what? It decreases. Question. Okay. Depression. Yeah. Because that was the question I was asking. So if I remove NO, I'm asking what happens to the concentration of O2. That was the question I was asking. So on the quiz, if I say, if I remove NO, what happens to the concentration of O2? Okay, that was the question. If I do this, what happens to this? I was just shorthanding it. Okay? Yeah, that's why. All right, so we're only be able to do pressure, we'll have to do temperature tomorrow, but we should be able to do pressure today. All right, so we can change pressure or volume, and this rule applies. So I did it the same way. I bolded the rule, unbolded are the reasons. So if I increase pressure, it will shift in a direction to decrease the pressure. So it shifts to the side of fewer moles, because fewer moles will decrease the pressure. If I decrease the pressure, it'll shift to the side to increase the pressure, which shifts to the side of more moles. Remember, this is a system that's at equilibrium, and we're messing with the equilibrium. We're trying to get back to equilibrium. And this is how it goes about. Now, in your mind, think about how you figure out the moles. What? Very good. You're regulating this. Fish. All right.
What questions were up at 10?
So coefficient equal mole. And this is the only stress that can have no effect. Now, why is this the only one that can have no effect? Why could this one be no effect? The coefficients what? They can be the same. Coefficients could be the same on both sides. You have 2 moles and 2 moles, or 4 moles and 4 moles. You can't get that in temperature or pressure. Okay? But you can get that, or sorry, temperature or concentration. You can get that in pressure. Okay? Everybody caught up? All right over there. Feel like you need to be on sleeping. Go over there, see Miss Thornhill. She'll sign you right up. All right, we caught up? All right, so let's say we have this. Anybody knows what's going on in my meeting this afternoon? Probably right. I want to go to the Chromebook right there. I'm probably the anything. I want to go to the Chromebook right there. I'm still on meeting once a month. More Chromebook. Well, so far since I've had a Chromebook, I found that several of the programs I use in my physical class, but I work on Chromebook. So I think they're all good. Especially being on the team, especially related technology.
So I thought.
Merwin County has the one-to-one program where everybody gets their MacBook or an iPad. I think K-8 has iPads and then the MacBook for the high school. Who does? Yeah, in Merwin County. All right, everybody got the equation? They sacrifice other stuff to put the money in. All right, so if we look at that, all right, look at what's there. All right, and we increase the pressure. What do we need to know first of all? What's the rule if we increase the pressure? All right, it's going to go to the side of fewer moles. All right, that means it's going to do what? All right, it's going to shift to the right or the product. So if I ask what happens to the concentration of NH3, what would you tell me happens to NH3? Hey, Dr. Curry, is fast as hers? Okay. NH3 does what? It increases. Okay? Now, what would happen to the concentration of N2 then? It would decrease. Okay? So anytime you tell me that it goes to the right, it increases, it decreases. Now, the flip side is true for decrease the pressure. If you decrease the pressure, what happens? It goes to the side with more moles. So, which side up here has more moles? Go to the reactive side. So if I said, what happens to N2 or NH, H2 or NH3, what happens to N2 here? H2 increases. And what happens to NH3? It decreases. Because anytime you tell me it goes to the reactant side, it goes this way, it increases, and it decreases. Now, your homework tonight is to look over Le Chatelier. We're going to add in temperature tomorrow and do all three. We're going to practice a little bit before we go to the talent show, and then we're going to start solubility and solution. Okay? Mostly we're going to do Le Chatelier tomorrow. But, yeah, we have an hour before the talent show. We have a legit hour so that you will not be behind first period. Remember, that was the thing y'all argued about